Hey guys, this is going to be a short video introducing the Cartesian coordinate system and graphing ordered pair. Okay, so in this first example, we're just introduced to the Cartesian coordinate system, sometimes called the rectangular coordinate system, and then these ordered pair. So what an ordered pair is where you have a pair of numbers and they're, in an order, because these clever names for things in math. It always goes x, y, and this is our x and this is our y-axis. And these axes can actually be named different things, but typically it's going to be x and y. If you get into physics or some application problems, that can change up, but that's kind of our typical. And x goes, positive the way it always has, and negative, to the left. And then for the y-axis, it's positive up and negative down. So this 4, 2, what this is basically directions on how to get to this point. It's saying we're going to go 4 over on x, so starting from right here, which is 0, 0, and this is called the origin. We're going to go 4 on x, so we'd count over 1, 2, 3, 4, and then up 2, 1, 2. And so that point right there, that would be A. B here would be 1, negative 3. So x is 1, so we're going to go right 1, but then y is negative 3, so down 3. And that will be B. C, 0, 0, that's the origin, that's what I was talking about right here. D, 0, negative 2, so our x is 0, so we're not going left or right, we're just staying right there. And then our y is at negative 2, that'll be right there. And then E, x is negative 2 and y is negative 4, right there. And then this one is just going the other way, so given the point, read the coordinates and write down the ordered pair. Careful when you're doing these on the computer. They generally, you'll see it a couple of ways. If it's just an answer box like that, you're going to need to type the parentheses and, whatever the number is, 4, 2 or something with that comma in there. Sometimes they'll have it where they have like this, and then you just type the 4 and the 2 straight into the box. But careful if it's an empty box like that you get those parentheses. Otherwise, it's not an ordered pair, it's a list, and that's a different thing. So that's a little bit important. So for A here, we're going right 2, so that means my x coordinate is 2, and we're going up 1, 2, 3, 4. So that would be at 2, 4. For B, let's see, we're going 1, 2, 3, 4, 5 to the left. So that would be a negative 5. And up 1, 2, 3. C, we're going left 1, 2, so that's a negative 2. And we didn't go up or down, so that means we just stay 0 on the y. D, let's see, 1, 2, 3, 4, 5, so positive 5, and then down 2, so it'll be a negative 2. And then E, we didn't go left or right, so that's going to be x is 0. So notice when we're on the x-axis, the y is 0, and when we're on the y-axis, the x is 0. Those are going to be intercepts a little bit later. And then this is 1, 2, 3, 4, 5, so negative 5. Let's see, so this one says, give the points, or actually just say given, sorry, I think I got that in the notes, but given the points negative 4, negative 1, and 2, negative 4, draw a straight line that passes through them and answer the question below. Do the following points fall on the line. So we're just going to take these two right here. So we're going to go negative 4 on x and negative 1. And then x is 2 and y is negative 4. So it's going to be like this. And so if I kind of look at it, I can kind of see it looks like it's going over 2, down 1, just to kind of extend my line. These are a little hard to draw. Okay, so I got my line drawn. And then we're going to come back and see if these points fall on this line. So if I take this first one, negative 6, 0, so I go over 1, 2, 3, 4, 5, 6, and 0, and yep, that one does look like it falls on the line. When x is negative 2, y would be 2, so that's a no, that's not on the line. And then when x is 4, y is negative 5. 1, 2, 3, 4, 5, yep. And so that one is on the line. Now the reverse to the last one, they gave us the line, and now they're giving us this table, and then asking us to find the corresponding points. So this little XY table, sometimes it's called a T table, it's just another way of saying negative 3 and then some value for y. So a lot of times we'll organize our ordered pair in a T table. So here, when x is negative 3, I can just go 1, 2, 3. So it looks like the y would be negative 2 in that case. When x is 0, so that means we're not going to go left to right, looks like y is 1. When y is 0, so when y is 0, we're not up or down, so that's right here. Then the x-coordinate for that would be negative 1. X is 3, so we go 1, 2, 3 on x. We go 1, 2, 3, 4, it looks like. So when x is 3, the y for that would be 4. And then lastly, what x would make the y 5? So I can come up 1, 2, 3, 4, oops, 2, 4, 5. So that's right here, and then trace it back down, and it looks like that's happening at 4. Okay, for this one, it kind of helps to be able to sketch on a little bit. So the rectangle ABCD pictured above has a length AD of 3 units and a width AB of 5 units. So let me show you what that kind of means in terms of the geometry stuff here. So AD just means the line segment going from A to D, and what they're saying is this right here is 3 units, and then the width A to B is 5 units. The point D, so right here, that point, is the ordered pair 6, 1. So right here we're at 6, 1. And then we're supposed to find the coordinates of A, B, and C based on that information. So if this is 6 and this is 1, this distance right here was 3, right? So if I'm at 6 and I count back 3, that means this right here would have to be at 3, because 3 plus 3 would make 6. Right here I'm at 1. They're telling me that this length is 5. So that means up there, this is going to be 6. So if I then kind of take that and put it all together, point A would be at 3, x is 3, y is 1. Put that over here. Point B, x is 3, but now the y is 6. And then point C, looks like the x is 6, and the y is also 6. 6 and then 6. Cool, so that concludes 2.1.